Hey you guys, end of the chapter. Hey, after this only 2 chapters left and then summer. We're going to do expected value today. So I've talked about how my husband and B's dad likes to go to Vegas and gambles. And so what he does is he analyzes expected values every time he places a bet on anything. He does a lot of sports betting. He does a lot of blackjack playing in Vegas. And so I have a couple of vocab words for you to copy down. Expected value is what you are estimated to win, for example. So an estimated or expected outcome in most likely a certain type of game. The notation we use is E of X. It looks kind of like the F of X from Algebra 2 when it was a function. So it's E of X for expected value of X. X being like all the possibilities if you're playing a certain game. And so a probability distribution, and we're going to practice drawing those. It's a sideways T-chart that shows all the possible outcomes with corresponding probabilities. And then common uses like I've talked about: lotteries, raffle winnings, prizes for gambling. And so very first problem, find the expected value of rolling a standard die. So like when you roll a die, you know how the options are 1 through 6. What do you expect to roll? I know how each one is equally probable. Each one has an equal chance of happening, but what do you expect to roll when you roll a die? So what we're going to do is we're going to start out by making a sideways T-chart called a probability distribution. I'm going to list all the different X's and all the probabilities of those X's happening. And so all the different X values for rolling a die are 1 through 6. These are all my options when I roll a standard die. And so the probabilities of each of them happening is 1/6 for each of them. And so when you roll a die, it's not difficult to figure out what are all the probabilities, but to find the expected value when you roll a die, all you're going to do is you're going to take all of your X values and multiply by the corresponding probabilities. So like this is here. And then I'm going to add 2 times 1/6, and that one is this one. And I'm going to work my way down. You just add them all up. So plus 3 times 1/6 plus 4 times 1/6 plus 5 times 1/6 plus 6 times 1/6. And when you add all of those terms up, you end up with your expected value anytime you roll a die. Which in this case, type it into your calculator to verify, you end up with 3.5. And so I wrote a couple of things down. After you crunch that number, just know what that number means. That means that on average, when you roll a die, you expect to roll between a 3 and a 4. And that just comes up with our expected outcomes for rolling a standard die. I also kind of filled out some of the vocabulary here. All the possible outcomes are listed here in my X column. All those probabilities of each outcome are listed here. And then remember, this is the notation for expected value. So rolling a dice is kind of a standard one, but like, how about example 2? If I have 20 different gift cards and I'm selling them for $3 each, it's kind of like gamble. 2 of the gift cards have $20 value, 5 of the gift cards have a $10 value, the rest of them have no money left. And so I'm wondering if I can make some money off you guys and sell these 20 gift cards and figure out if any of you guys are willing to take a gamble. Okay, and so if you buy a gift card from me, what is your expected net monetary gain? And so, yeah, you could kind of think to yourself, am I willing to like gamble here? I'm not really sure. We can actually come up with what do you expect to win in this scenario. So I'm going to first draw the probability distribution. All the different options for X, that means my like winnings. I'm selling all of them for $3 each, so you're going to buy a gift card from me for $3. 2 of the gift cards have a $20 value, so that's one of my outcomes. That's one of my possibilities. 5 of the gift cards have a $10 value. That's another option of winning. And the rest of them have no money left, so 0. And let's come up with probabilities of each one. So all of the probabilities, what is the probability of winning a $20 gift card? So 2 out of the 20 is the same thing as 1/10. You can reduce them more, you don't have to either way. How many of them have a $10 value? 5 out of the 20, so that reduces to 1/4. So the rest of them, which is 13, have $0. You could also convert all of these fractions to decimals if you want. It doesn't matter, but we are going to actually crunch what do I expect to win if you guys pay me $3, what do you expect to win out of these gift cards? So I'm going to crunch my expected value, and I'm going to use that notation. It's $20 times 1/10 plus $10 times 1/4 plus $0 times 13/20. And yeah, that cancels out it just to 0. Okay, so our expected value here is $4.50. However, remember this part up here, how I'm selling them for $3. So you technically paid me $3. And so you are expected to really only make $1.50 in this case. So don't forget to subtract whatever you paid, like for your lottery ticket or whatever, because that subtracts away from your winnings. You do have to pay something in order to play this gift card roulette, basically. And so when you subtract your how much you paid, that ends up with your total net winnings. That's what net means. Net monetary gain. I'm going to make a note about that. That means after subtracting what you paid. Okay? And so that's how we come up with $1.50. So would you be willing to play this game if you are expected to make only $1.50 on average? There is a chance you could get one of my $20 gift cards. There is a chance you could get a $10 gift card, but there's a really high chance that you would get a $0 gift card. So would you be willing to pay? That's the question. You are expected to win in this game. A lot of times this number ends up being negative. I would not play that game for sure. Here's a pretty simple problem, number 3. How many hours of homework are done each night? Percentages of survey responses shown below. So all the X values are all the different responses that people said each night spending time on homework. 0, 1, 2, 3, and 4. And so I guess the least amount of time spent on homework is 0, because some people don't do homework at all. And the most amount of time in this survey is 4. So 4 hours of homework each night. Percent of those surveyed. So here's something weird. We're given a question mark here, but the percent is shown. So 31%, 25, 16, and 12. That means the remainder goes here. Because remember, all of these, essentially kind of like Y values, they are all supposed to add up to 1 because all of these include every single possibility. Remember that vocab word sample space? This is the entire sample space, all the different outcomes that are possible. Therefore, all of these probabilities need to add up to 1. That is how I come up with a 16 right here. And just be careful because these are percent. I'm going to change all of these to decimals so that I don't screw up my math. This is 0.16, 0.12, etc. So add those decimal points in since those are percents. What is the expected number of hours of homework done each night? Go ahead and do your E of X formula just like this and come up with an expected number of hours of homework each night done by all these people. And so here's what the work looks like for the formula. I took my 0 times 0.31. Yes, that just gives you 0. 1 times 0.16 all the way down and added them all up. That means that if I randomly selected one person, I would expect their answer to be somewhere between 1 and 2 hours of homework on average. And so the point is, if I just asked what's the average number of hours of homework, you can't just average 0, 1, 2, 3, and 4 together, because there's a lot more people that studied for 0 hours than 4 hours, for example. So 0 and 4 are not equally weighted. It's the same exact thing when we weight grades in the categories in the grade book. And so homework, even though there's a lot of homework points in the grade book, it doesn't count as much as a test. So you can't just average all your total points together. It's the same idea as this. Okay, let's go on to number 4. In 4 years at Fremd, I got A's in 15% of my classes, blah, 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 blah. What is the GPA? And so remember, an A is 4, a B is 3, a C is 2, whatever. So instead of putting A's, B's, and C's in my T-chart, I'm going to put 4s, 3s, 2s, and 1s. And I have probabilities of those. So the A category, the probability is 15%. So an A is 4. That's what an A is. So you can put an A, but I need a number in order to do my calculation. I got an A in 15% of my classes. I got a B in 30% of my classes. I got a C in 40. I got a D in 0.1, and I got an F. I got an F in 0.05. So quick check, remember that all of these are supposed to add up to 1, and they do, because that represents all the grades that you got throughout your whole high school career. And so to come up with my expected value, all I'm doing for E of X is taking the 4 times 0.15. That's 15% of my grades are A's, 30% of my grades are B's, and then you're going to add all those up, and that is your GPA, and that is exactly how GPA is calculated, you guys. And so here's what all that work looks like. Remember, you're just taking the A, which counts as a 4, times 0.15, plus all the B's, which is a 3, times 0.3, and all those are all the corresponding percentages. So again, you're not just averaging A through F together, because your B's and C's happened a lot more than your D's and F's did. And so that ends up with an overall GPA of 2.4. Okay, very last problem is about a lottery ticket. What I'm going to do is lottery tickets sell for $1. So remember, I need net expected value. After I pay to play the game, I'm going to have to subtract that $1 that I paid for a lottery ticket once I figure out what my earnings are. So all the different options of earnings, I have a 1 in 20 chance of winning, $10. So my first option is winning $10. The probability of that happening is 1 over 20. Not very good. I have another option of winning 10 grand. That would be pretty sweet. But the chances of that are much less, 1 over 100,000. And then anything else, I would win $0. And so the question is, first of all, do I have to come up with this number? I could, because remember how they're all supposed to add up to 100%. But when I do my formula, aren't I going to do 10 times this plus 10,000 times this plus 0 times whatever that is? That doesn't even matter. So you could figure out what the chances of winning nothing are. It's going to end up 0 in your formula. So you don't have to waste the time with all the fractions and stuff. I'm just going to come up with my expected value here, which is $10 times 1/20 plus $10,000. That would be really sweet. 100,000 plus 0 times something. Nobody cares what that something is. Okay, crunch that number. And we end up with expecting to win in this lottery 60 cents. Okay, so great, we won 60 cents, right? But remember, we paid $1 for the ticket. So you actually ended up losing 40 cents playing this game. MB would not be happy with me if I bought one of these lottery tickets. He despises the lottery anyways. He always knows that you're never going to win. And so therefore he's always thinking expected values here. And most of the time in lotteries, you guys, the expected value is negative. That's why nobody ever feels like they win. Sometimes you get lucky. Most of the time you end up losing money, as you know. So just make a major note here to make sure that you understand what net expected value is. That means you have to subtract the amount of money that you paid to play the game or buy the ticket or whatever. So net means after you pay. So subtract that $1 away or however much money you spent, and that ends up being your net expected value, okay? So hopefully that made sense. Remember a couple vocab words. This T-chart thing is called a probability distribution. This is our notation for expected value. Net means after you subtract what you paid, okay? Hopefully that made sense. Good job. You guys are done with the chapter. I will see you tomorrow.